With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, so generally this question is based on assertion and reason. So we have to state here whether both are the correct or not, and the reason is correct explanation for the assertion or not. Okay, so for this, first of all, let's see the assertion first. That is, for a practical choke coil, the power factor is very small. Reason: in practical choke coil, the power dissipation reduces if frequency of NEC is increased. Okay, so let's see solution. So first of all, to solve this question, we have to know about the what is choke coil. So generally, choke coil is used in tube light. Okay, you have seen the tube light in your own house, in which in the middle of it a box is placed. So this box is generally called as choke coil. Okay, now the purpose of choke coil is to reduce the EMF across the light. That is, generally the supply voltage coming from our house board is of 220 volt, but the voltage requires for the tube light is only 50 volt, right? So to reduce this EMF of 220 volt up to 50 volt, this choke coil is connected in series with the tube light. Okay, now you will say we can connect a resistor too. So yes, we can connect a resistor in series with this too, but in that case the power dissipation will be more, because we know that for inductive circuit the voltage consumption is more, but the power consumption is negligible, which we can say as power consumption is approximately equals to 0. Okay, why? Because if we talk about LR circuit, okay, let's say to clarify this, let's say a LR circuit. This is an R, this is an L, and we have supplied an AC source across to it. Okay, now for the circuit, the power dissipation can be given by the formula, that is P is equals to IRMS square into R. Now if you look at here, so the power dissipation is totally dependent upon the current flowing throughout the circuit and the resistance of the circuit, not the inductance. Okay, so here I can say that the voltage consumption for the inductive load is more, but there will be no power consumption. Okay, now according to question, what is given here assertion, that is for practical choke coil the power factor is very small. Means for a practical choke coil power factor is very small. And why is it small? Because the choke coil power dissipation reduces, its frequency of AC is increased. So for this, let's look at this circuit. Okay, if we talk about this circuit, so for LR circuit, we can say that the impedance Z can be given by the formula, that is Z is equals to XL square plus R square. Okay, where XL is the inductive reactance. Okay, while to get the power factor for this circuit, we have to consider the phasor diagram, right? So let's say the phasor diagram for this can be drawn like this, in which this is an R, this is XL, this is impedance, that is Z, and the angle between this impedance Z and R is phi. So generally the cos phi is denoted as the power factor for the circuit, and it is given by the formula, that is cos phi is equals to R by Z. Okay, now to get smallest value of cos phi, here the value of Z should be more, and for value of Z should be more, the inductive reactance, that is XL, should be more. So in that case this inductor value, okay, means this L value should be more. Okay, while we also know that the XL is given by the formula that is L into omega, where omega is denoting the frequency. Okay, so to get the value of XL as more, the frequency should be increased, that is value of omega should be increased. Okay, so here I can say that this all the thing, that is cos phi, Z, XL and this omega, that is frequency of the circuits, all are interconnected with each other, right? Because one will increase, so it will decrease, and this decreases because of increase in XL, because of increase in frequency, right? So here I can say that for practical choke coil the power factor is very small. Yes, it is very small, because to reduce this much of voltage, that is 50 volt from 220 volt, the inductive reactance required for the circuit is more. That's why the power factor is very small, while this is very small because of the power dissipation reduces, that is the frequency of AC circuit is increased, because it is only possible when this frequency will increase, so XL will increase, so Z will increase, and it will get reduces the power factor, that is cos phi, okay, which we want here, that is very small. And the power dissipation is also denoted by the formula, that is P is equals to Vrms into Irms into cos phi. So obviously if this cos phi reduces, so power dissipation will also reduces. Okay, so according to this all discussion, the assertion is true, while the reason for this is also true, and the reason is correct explanation for the given assertion, right? So according to given option first, that is assertion and reason are true, and the reason is correct explanation of the assertion, will become correct answer for this question. So this is the required solution. I hope you will like this solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.